The next presenter for the part on structural analysis, verification, and design of interventions, actually there are two. It's going to be shared by Professors Isakovic and Kappos. So I've already introduced Professor Kappos, Professor Tatjana Isakovic from the University of Ljubljana. She's a full professor of the Faculty of Civil and Geodetic Engineering at Ljubljana, Slovenia. I also remember very well, personally, Professor Isakovic. When I was starting my first presentations in conferences on bridges, I remember her asking questions on my work. So it is very nice to be able to introduce her today. Her research interests have focused on bridges, but also precast buildings, walls, and base isolated structures. She's also the president of the Slovenian Technical Committee for Structures, Slovenian delegate, national delegate for the Eurocodes, and a member of the Working Group 11 of the European Association of Earthquake Engineering and International Wall Institute. So Professor Isakovic.
Thank you, Ricardo, for the introduction. I'm going to talk about the chapter 6, which deals with modeling, structural analysis, and verification. But before I start with the details, this is some summary of the basic features of Eurocode A3, which is important for the analysis and for the verification. So there are two approaches: a displacement-based approach, force-based approach. For limit states, these things were already addressed in the previous presentations, but just to make a summary. And for general types of analysis, the red features are the preferred features. So displacement-based approach, near collapse limit state to be checked, and the default, let's say, analysis is simplified nonlinear static pushover-based analysis. But as you can see, the other options are also available. Let's go to the modeling. When we prepare the model, first of all, we have to check if our structure is already damaged or is undamaged. I will show later the seismic action effects should be increased where the structure is damaged. As already mentioned in previous presentations, big change comparing to the current version is that the mean material properties are almost always used, with the exception that Paula mentioned, and I will not explain this again. So this is a great simplification comparing to the current version where different material properties were used. What should we model is, of course, the mass stiffness damping, and since the displacement-based approach and nonlinear analysis is preferred, the strength and deformation capacity. So there were questions how to do that. There are many possibilities, actually. I showed here, for example, one option where we have the simplest model, which can be used. It is a model with lumped plasticity, but as you know, there are also other options. But what is the point that if we perform, for example, response history analysis to describe actually how the model or the elements respond? There, it depends on the type of the response, whether it is ductile or brittle or what is critical. One can say, where can I find some instruction how to define this these values? Here we have generalized forces and generalized deformations. which can be moments, rotations, or curvatures. These values can be found, the instructions can be found in part 1.1 in chapter 7 for different type of materials. But what is expected here in Eurocode 8.3, since we are dealing with existing structures, that we model also this degradation of strength. And this is actually, it is not necessary in all cases. It depends what we are doing. This is required when the global verification is performed, and we will talk later about this. So some instruction can be found in part 1.1. These were in the past in Eurocode 8.3, but since they can be used also for new structures, they are displaced in this general part. So these were models for nonlinear analysis. Of course, for pushover, the envelopes will be used. Eurocode 8.3 also allows some simplified displacement-based approach, which means that we can perform the elastic analysis with unreduced spectrum. This is not force-based approach. I have to stress this. But again, force-based, displacement-based approach, because we are dealing with unreduced seismic action, we have to check the displacement, generalized displacement capacity. Here, it is very important to model properly the elastic stiffness, which should be the elastic sectant effective stiffness corresponding to elastic limit states. For example, in concrete structure, this is the stiffness corresponding to the first yielding. But there are some simplification also allowed. Paula mentions already preliminary analysis, where it is written that 1/4 of the gross cross-section properties can be used, since we are dealing with actually near collapse states and a nonlinear response. Force-based approach, as Professor Kappos already mentioned, it is allowed because designers requested this. But in this case, also some elastic stiffness should be properly modeled, and some simplifications are available in relevant part for buildings and bridges. Let's go to the nonlinear analysis. As I said, the nonlinear static analysis is prepared. Here, there are not a lot of changes regarding the current versions. Everything is regulated in this general part of Eurocode 8 and parts for buildings and new buildings and bridges. But what is probably changed comparing to the current version, that only one distribution of lateral load is required, proportional to the fundamental mode of vibration. This is written in the first part. But for some existing structure, additional analyses are required. For example, if we have soft story in a building, then uniform distribution pattern should be also taken into account, and some other requirements for masonry buildings are also here in Eurocode 8.3 required. Of course, the corrections due to the torsion and higher modes, which are described here in these two parts for buildings and bridges, should be performed too. What is also probably new for nonlinear static analysis, it is not directly included in Eurocode 8.3, is that different shapes of pushover curves are now addressed, and also different kinds of idealization. It is not only elastic, perfectly plastic, but here you can see this is, for example, some typical pushover curve for bridges in the transverse direction supported at the abutments. So when we have very irregular structures, then the non-linear static analysis is not appropriate anymore. In such cases, the nonlinear response history analysis should be performed. These are two examples of such structures. And in such cases, the loading is defined again in a general part of Eurocode 8 in Annex D, how the accelerograms should be chosen. Elastic linear analysis with unreduced acceleration spectrum is also allowed, as I said, but only for regular structures. And how the regularity is defined, comparing the action effects and the resistance in different elements. If there is a large difference in differences in these different elements, then this method cannot be used, because in such case it's a significant distribution between members can be expected if these values are larger than these limit values, and elastic analysis cannot address this. Force-based approach, the use as limited is allowed in low and moderate seismic regions. As already was mentioned, Q factors are lower, 1.5 or 2 for steel. And here only the overstrength is taken into account. How the low and moderate seismic action is defined. It is defined again in a general part, but using this maximum acceleration in spectrum, but for return period 475 years. I think personally this should be harmonized with the near collapse limit states where the return period is larger. Then there are topography coefficient, the type of soil, and parameter delta depending on the consequence classes. Here I made some preliminary calculation. What does it mean when we use this return period acceleration? PGA is about 0.2 G. The limit value, if it is larger than this approach cannot be used. And the last topic is safety verification. As I said, if we have already damaged structure, the action effect should be multiplied by factor 1.15. As was already mentioned in previous presentation, the return period since near collapse limit states is let's say default, preferred. The return period is larger, and the seismic action also. And the verification can be performed in local and global terms. Here it is not decided, as Professor Kappos already mentioned, when the global terms can be performed. But it is clear that it can be performed only when the nonlinear static analysis is performed. In other cases, local verification should be carried out. But in general, it is mentioned that the global verification will be carried out for masonry buildings and buildings where the infills dominate the response. When the verification is performed in local terms, then of course the generalized deformation should be compared with the resistance, which is defined in a same manner, taking into account the yield, let's say curvature, and plastic part divided by the appropriate partial factors that Paul already talked about, and can be found, these factors can be found in other parts of the Eurocode 8. If we have if we're dealing with a brittle mechanism, then brittle mechanisms, then we have to check this in terms of generalized stresses. For example, shear resistance should be compared with shear forces, which have to be calculated out of non-brittle mechanism in a similar manner what we do with a capacity design approach. And again, in a global terms, it is mostly intended for masonry buildings and where the infills are predominant, but only if the influence of torsion and higher modes is not too large. So the other limit states here probably for significant damage, this is the change regarding the current version where the capacity for significant damage was 75% of that of near collapse. Here it is calculated a bit differently. This plastic part is half of that at near collapse states. The other two are actually elastic limit states, and the damage limitation, the upper bound is yielding, operational limit states is regulated with other parts. Thank you very much.
Thank you very much, Professor Isakovic. I would suggest we would proceed now to Professor Kappos, and then there is a question that has been raised, but I would leave that to the final part of this block